Oh, hello, good evening.
Hey, good evening, Mr. Akin. Can you hear me?
Yes, good evening. Welcome to class.
All right.
So there are just two of you in class, and this is 5 minutes past 6. You are just joining, the other guys not here. So was there any problem? Was there really?
Yeah, Zoom. Yeah, I had to sign out and sign again in Zoom. It was giving me problems.
Okay. So the other guys not here yet. So normally with just two people, I will postpone the class and see if I can do more advert to get 3, 4 more people to join. But
Okay.
I felt that, especially for you that has shown some kind of commitment even before since last year again,
Mhm. Yeah.
it would be disappointing to people. But encouraging that just two of us, and then one will join late. At least we can forgive this first day. And just so okay.
Yeah, no worries. Yeah, the first day, yeah, everyone's joining and everything. But it's already, since this is what we want to do,
Okay. So we have to be prompt so that at least we can keep it alive.
Mm-hmm.
So it's 6 minutes past. Just start skeleton. So it's being recorded. Whoever is not here would. I'm hopeful that in the course of the training, a couple of people will still join so that it's not a lonely class. All right. So in the time being, let us start. So let me share screen. Okay. So this is DevOps. DevOps1. So we divide the DevOps class, or my DevOps class, I have divided into 2. So I call the first part of the DevOps, DevOps1, and I call the other part DevOps2. So this is the first part for 1 month. So this first part will last 1 month, and then DevOps2 will be another 1 month. So $600 per module. So altogether, we are looking at 1. All right. So just for the record, it may not be for you, but for people that will be seeing this later. So DevOps1 is for 1 month at 600. DevOps2 is for another 1 month at 600. So together, it's a 2-month course. 1,200. All right. So this one this is the one we are starting now. All right. To start this one now, we'll start from the very basics, from the very fundamental. So what is DevOps and what is the place of DevOps in IT? All right. So there are, from the viewpoint of a DevOps engineer, there are 2 aspects to IT. IT is very, very wide, but seeing it from this viewpoint, there are 2 aspects to it. There is the operations, which we call ops, and there is the development, which we call dev. So once somebody that is going to be a CEO or a business owner or a business idea owner comes up with a business idea, that business idea, in order to convert it to a technical subject that can be converted to an application, would have to be converted by business analysts to technical terms that technical guys, the IT guys, can understand. So from that point, they will hire developers, programmers, we used to call them. The modern name is developer. All right. So these developers will work from across the world. to write codes and contribute these codes into a central place that we call code repository, right? So from this code repository, we would have all of our codes built. If the application is going to be Uber, for example, or the application that drives Tesla, the applications will all be here. 1 million, 2 million, 3 million lines of code contributed by different developers. Developer 1, developer 2, developer 3, 4, developer 75, and so on and so forth. So this code repository, we also call it, in fact, it's more commonly called a version control system. And the tool that is used to communicate with this version control system so that you can pull codes from here and push codes and manage codes. That tool is usually called Git.
Right? Okay, sorry for interrupting. Yeah. I don't know if you're sharing a board with a drawing or something, but I see the Word document instead.
Oh, okay. Sorry.
Yeah.
Yeah. Okay. Sorry about that. So this is what I was sharing.
All right. Yeah, okay. I can see now. Yeah.
So there's developer 1, developer 2, developer 3. This one may not be one person, business owner. So we just call all of these people, be a group of people, stakeholders. And then that was the business analyst. Okay. So we use Git as the tool to communicate, not just to communicate, to manage these codes between this developer and the code repository. So it is from here that we pull the codes and then build the codes into artifacts. Artifacts. All right. And then this is the artifact that we later on build into image. And it is this image that will now deploy to operations. In operations, normally would have a server configured, maybe EC2. All right. And then we'll take this image and then we create a container inside this server and deploy that image into this container. When an image is deployed into a container, then we have an app. So this becomes the final product that originated from the idea here. All right? So it is this application that is now available to the world to see that, oh, to your users or your customers or whoever it is that you have prepared this application for, they are now able to see it and make use of the application. So everything that happened outside of operations, from the point of coding all the way to just before the application was successfully deployed into operation, we call that part of development. And once we are in operations, that is within cloud now, we have our server running and everything you are going to learn in cloud is operational here. We call that operations. Another way to look at it is this development part, we call it continuous integration, CI. And this other part that happens in operation, we call it CD, continuous deployment. So this is how codes are built. And then ultimately, this is how codes are written and then saved in a code repository. And then from there, they are pulled and built into artifact. And then the artifacts are further converted into image. It is this image that will now take and deploy to operation. So as a DevOps engineer, usually there is a war between developers and operations, between development and operations. As a DevOps engineer, your work is to eliminate this war so that there is no longer demarcation, no longer this is DevOps, this is operations. No, they now become one, DevOps, through your work. So as soon as the code is written, it is as good as the code is built and deployed into operations, because there's no longer separation between them. You can liken this to in the world you have the field of oil oil, and then the drillers will drill the oil, and then to put the oil, sieve the oil in some oil container, maybe badge or whatever they call it, and then you now have trailers coming to take that oil and transport that oil to a refinery where the oil is refined to the final product, and therefore from there it is available to the public. Right? So this is the raw state, and this is the finished state for that oil, or in this case, for this application. So the creation of the code at one end and the finishing of the code in the form of application at the other end is what we call end-to-end deployment. So as a DevOps engineer, your work is to work collaboratively with this unit, these developers on one hand, and also with this unit, operations on the other hand, to ensure that the codes that are written by developers are converted to applications and deployed successfully in operations. After the codes are successfully deployed as applications, there is one more thing you need to do as a DevOps engineer to complete your work as a DevOps person. This application needs to be monitored. The infrastructure, that is the hardware, the servers, the firewalls, everything around operations in which the application is running, they will need to be monitored. They are called infrastructure. And the application itself, running inside the infrastructure, they will need to be monitored so that you can get feedback relating to the insecurity or vulnerabilities of the application, the resources that the application is using, how it is using the resources. And you have to learn about the application to see how to improve on the application. So the
Is this also, sorry to interrupt. Is this also where we have to also monitor once a lot of people download the app or use the app, maybe it grows from 1 million to 10 million?
Yes, correct. It's all part of the monitoring. Yeah. So all of those monitoring would have to be put in place so that you can monitor. So you have to install monitoring tools. And then these monitoring tools will bring feedback to the developers. And then they will now see, oh, this application was meant for 1,000 people. Now we have 1 million people. So we need to do something. Otherwise, it will crash. The resources will not be enough. So it is from that monitoring feedback that these guys will work to improve on it. And then we'll keep monitoring. We'll get feedback again. We improve on it. We keep monitoring. So for that reason, we have something that would ultimately look like right? We have a diagram that look like this. So from the stage where the idea of building an application comes to you, it's called the planning, to the stage where you code, where the coders write the application, to the stage where you build the application and then test. At this level, we actually don't call it application. Everything happening here is still code. So this is the planning stage, the coding stage, the build stage, the testing stage. All of this is part of the development. It is once when you have tested the result of your build, coding, of your planning, coding, and building, and you are satisfied with the result, that is when you now release the artifact into operation. So this is release. And then when you release, it becomes, so you release, and then you deploy into this area. Then after you deploy, it becomes operational. So the ward or whoever you deploy this for can see, and then you monitor. And then from the monitoring, you get feedback about how the application is behaving. And then you improve on all of that in the application, in the development stage, and then you release again to operation. And then it's monitored. Something happened or something, and then just like that. So it just keeps going. So this is the sign for infinity. It keeps going forever and ever. So this part where you need to modify the code is development. And this part where you release the result from there to operations is otherwise called CI/CD. All right, any questions? So as a DevOps engineer, this will be your place. So you'd have your laptop or your system somewhere there. And from here, you'll be able to coordinate all of the activities of operations and develop. There's collaboration. They are working together. It's not like the old system where developers are different from operators, and no. Although they are not operators, but it's a team made up of both developers and operation.
Okay. Will you say that the real DevOps is a person that his jobs or he or she's job starts when the testers finish and the release starts? Or is it the entire thing that means DevOps?
Yes. The DevOps engineer is involved in the entire process, all the way from build, all the way from the idea to building, to coding, to building, and all of that is involved. The reason is because if you want to build a strong house, you don't lay the foundation of the house before you call an engineer to come and take over. So the engineer will be part of it from the very, very beginning, from the planning stage. Right?
Okay.
Yes. So DevOps is involved in all of that. So the DevOps is the guy that is the middleman, that is the bond between developer and operation. So for that reason, the DevOps person needs to know a bit about development and so much more about operations. And this is the reason you are doing the other course you are doing, so that you learn about operations. Because as a DevOps person, you should be very familiar with this. Because as a matter of fact, to be honest, these days, even though in theory we separate the roles here, these days it is very, very usual, very common to have this DevOps person be the one who would actually set up the system and deploy the application into the system. So IT is converging to a level where only one person should be able to do all of this. Maybe not now, maybe in the very near future, everything. Unlike previously, where we would have one person do this, another person do this, another person do this, and so on and so forth. This person that is doing all of them may not know the details, nitty-gritty about everything, but at the overview level, at least he should understand why the application he's trying to deploy into an EC2 is not working. And at that level, he shouldn't wait to go and call an operations person as much as possible. He should at least attempt to see why it's not working, fix the problem, and be able to deploy. So to repeat what I just said, I am saying that as a DevOps person, since you are coordinating these entire activities, you should know about operations and you should know about development. Not in terms of learning to be a developer, but in terms of learning how to use JIT to manage code. And here, not in terms of learning everything in cloud, but in terms of knowing enough in cloud to be able to set up an application. And that is what we'll be learning on that cloud solutions architect when we go into AWS.
Okay. So the operations part is more handled by the AWS developer or AWS cloud engineer or
yes,
solutions
AWS cloud engineer. Yeah, okay. They are the same thing. Yeah, AWS cloud engineer, AWS solutions architect. But to be more specific, solutions architect is the best.
Okay.
Right. Mm-hmm. So you cannot say you are a DevOps engineer if you do not know what happens here. No, you cannot.
Okay.
Yeah. So that's why in our courses, we first of all say the first 2 months here, and then the second 2 months, haven't mastered everything that happens here, will now extend your knowledge to now include what happens here. So second 2 months. So altogether,
okay.
Solutions architect, and then DevOps engineer. And for what happens here, we would teach you all of this as part of 2 months. That's what we're starting with today.
Okay.
All right.
All right.
I hope, let me just send this guy a message. I hope you registered for this course and not for a different course. Or maybe I should even call him so that you are not.
Yeah, no worries. I can wait. Yeah.
Okay, just bear with me. It was a class of 10, 20. I mean, more people I wouldn't. So let me just see if I can. All right, I'm back. It's not picking, so I guess it's.
Okay.
All right. So any questions so far?
Not at all. Very clear. Thank you. Yeah,
okay.
Very clear.
All right. So for the note now, what are we doing? Okay. So there's a concept called agile methodology. So that is basically saying that as software developers in IT, when I say software, I basically mean something like an application, like Uber application, GrubUp application, all of those applications you hear about. So the people who write the codes for those applications, they are called developers. And that application is called software. Okay. So if you want to create a software, you don't know what will happen in 15 years' time. You don't know what will happen even next year. So even though this is the idea of your application, for example, the application will have different parts. One part that will take input from the user, another part that will contact the backend. So different parts of the application, even though this is what the application is going to look like. You don't wait to complete the entire application, the coding of the entire application before you release it to market, to operation. So what you want to do is create just the basic part of the application and launch it into market. Maybe you create only these 3 parts. All right? And then once these 3 parts, 1, 2, 3, it's not a full application, but it's just a basic part that is doing the basic thing for customers. And then you release that part into the market. Right? So customers are now seeing that part and they are using it. And based on their feedback, you are modifying and improving on it. All right? So in another 2 weeks, you gather your team and say, the part that we released to the market is doing fine. Now, on top of that one, we want to add a new feature. We now want to add this other part, this blue part. So you come to your developers and you say, this is the blue part we are working on. They work on this. And then once they write the codes for that part and it's tested and it's ready, you launch and add it to what you have. Another time you say, oh, that is beautiful. We are doing well with that. Now let us add this other new feature, the gray part. So we discuss this at the meeting, we build it, we test it, it's working, then we push to operations, we have that part. So we call this concept of continuously, first of all, this concept of breaking down the whole application into small modules that we work on at a time. That's what we call agile methodology. Agile methodology, right? And then we call these iterations, these modules that we work on. This is what the Scrum guys will call a sprint. So this is usually developed every 2 weeks, sprint, right? So this iteration, we just keep adding the iteration. So this idea of not waiting to build the whole application, but building them in small modules and improving upon them is called, this method of developing software is called agile methodology, right? And each of this is called, is created within a period of time called sprint, and it's called an iteration. So that's where you would hear or you will find in your job description that we're looking for a DevOps engineer who is familiar with agile methodology of developing software. Anyway, there's really no other methodology now other than agile. I mean, that's what is in vogue. Technology is moving with time, and at different stages and different eras of technology, something is reigning. After a while, it goes off and better technology comes up. But right now, all of the software development that are in vogue now, they are built around this methodology. It's not even worth talking about other methodologies. Agile methodology is the one that. So, as a DevOps engineer, you are working under this method with this methodology of developing what? Software. All right. And then this is the diagram we drew earlier on, if you still remember, where we said the whole DevOps process involves planning the application, writing the application out in codes, building the codes into artifacts, that's what it's called, testing the artifact and making sure it's fine. And then once it's fine, it means that the developers have completed their own end of the job. So what happens from there? It is released from the development environment into operations. Once it is released into operation, the application is now deployed in your server, and then it becomes operational so that people, the world can see. But your work does not end when the world sees it. We plant monitors to continue to monitor the application, and from what the monitors, from the feedback of the monitors, we are able to improve and then repeat that. All right. So for this, we are going to use different, let's take this. Okay, see. All right. So in order for us to write codes, when it comes to not writing codes, we are not writing codes. So, but in order for us to deal with codes, the codes that have been written, in order for us to interact and be able to manage those codes, we need a tool called Git. We're going to learn to use Git to manage codes. In order for us to build the codes, in this case, we'll be working with Java codes. Codes can be written in different programming languages, but the codes we'll be dealing with mostly is the codes written in Java. We are choosing Java because that is the most popular application used to develop enterprise. That's the most popular software used to develop enterprise applications. Everything we have chosen to use in this course is because they are the most popular in the market. And that is what job recruiters and employers are looking for. All right. We'll use JIT there. To build the code, we are going to use Maven. To test the code, we use Maven as well to test code. To release the code to operations, we are going to use Jenkins. So these are the tools that you'll be learning. Jenkins. And to deploy the codes to operation, we are going to use Docker. To operate the codes, we are going to use everything that you have learned in AWS. To monitor the codes, the application, once it is here, we'll call them application. Once they are still here, we'll call them codes. So bear with me. So to monitor the application and the infrastructure that you are running in AWS, we are going to install the tool called Prometheus on Grafana. Right? And then you just keep doing that. Right? That never stops. There's always something to do. There's always a feature to add. There's always something to improve. There's always a vulnerability to check. There's always something to do. So it just keeps going forever. All right. So that is what we have in the note here, explaining. First of all, did you get the concept of continuous? Because it never stops. It just keeps happening forever and ever. That's why we add the term continuous to everything that we do.
Yes, that's right. Yeah.
So continuous version control. That is the part where we have forgotten. All right, so we said the developers are working. Another developer here, another developer here. All of them are working and contributing to this central place. So this code in this central place are managed through JIT. And this is what we call version control system. It's a continuous process. You manage, you push, you pull the codes, you improve on it, you push again. The next day you resume, you pull, you improve on it, you push. So it just keeps going. All right, so this is the continuous version control using JIT. So that's what we have in the note here, saying that for continuous version control, we are going to use JIT. So where did we get GitHub for the first time? So this is what we mean by GitHub. This place where we save the code to and pull the code from. The general name for places like that is version control. But the specific application, the specific tool that we'll be using for our version control is GitHub. All right. Have you heard these names before? These names that I mentioned? GitHub, Maven.
Okay. Yeah, I've heard except Prometheus. I think.
Okay.
Yeah.
Good. What's your background again? Let me let you introduce yourself.
iOS. Yeah, iOS mobile.
Oh, okay. Yeah, you are the iOS guy. Okay.
Yeah.
All right. Okay, so we'll come back to the note. Then for Maven, that is what we use to build our code. We're going to learn to use it. This is not hard to learn at all. And then to release the code, like we said earlier on, this release part, okay, we're going to use Jenkins. And then for containerization, talked about Docker, we'll use Docker. Then to set up our infrastructure in cloud, we're going to use Terraform. But Terraform is not for this class, it's for the other class. You learn Terraform from there, and then you'll be able to use it here to set up your infrastructure. However, we are still going to use Terraform here. If you understand it here, fine. If you don't, by the time you do it properly in the other class, which is in another 5 weeks, then you get it. And then there is a tool called Ansible. We're going to learn it, and we're going to use it. That's the last tool we'll learn. And then Prometheus and Grafana, we'll learn that as part of DevOps 2, not here. All right. So that's the overview of what we will learn in DevOps, and that is the architecture of DevOps. So for you to get a job as a DevOps engineer, you must understand this architecture enough to be able to explain it like I just explained it, at least at the first stage of the screening interview. The recruiter that is calling you would be testing to see if you understand this workflow, this diagram. And then at that level, he expects you to mention that, oh, for the build, I use Maven. For the testing, I use Maven. For release, I use Jenkins. He expects you to mention as many of these steps as possible as they relate to this diagram here. Once you're able to do that and they ask you a few questions and you get it, then you are shortlisted for the interview.
Okay, that's the screening call now.
Yes.
Okay.
All right. Yes, this is basically, it's really important. DevOps is not about just using the tools. So it's really important to get this concept and understand it and be able to explain it. Even in the industry, they'll tell you, it's not about, the tools are just implementing a concept, an idea, a methodology that you know. You could use any tool to implement that methodology. So it is more important to understand the culture, DevOps as a culture, as a way, as a style of industry life than to understand the tools. So that's why we're taking time to understand the basics before we go into. All right, so for that reason, let's do another high-level overview of application automation in DevOps. But before I don't talk alone for 3 hours and get tired, so let's find out a bit of what you know. I'll let you do some talking. All right, so let me come back here to, let's come here. So do you know the different stages that are involved in the DevOps process?
Yeah. Stages in the DevOps, the infinity cycle, right?
Yes. What are the different stages involved?
So we have the planning phase, and from the planning we have the code. From the code we have the I think build or test.
Are you seeing my screen? It's right here. So the planning stage followed by coding, then what?
Yeah, build and then test. Yeah, and then deploy. It looks like the same thing. Yeah.
Yeah, it's the same
Release.
thing.
Yeah. Deploy. And then we have the release, I guess. That's the one that's missing.
Yeah, so the integration here is the release.
Okay.
See this sign? See, releasing from the blue part to the orange part. See this sign?
Okay.
Yeah.
Okay.
All right. And then deployment, operations, and monitor, right?
Monitor, yeah, and then back again.
Yeah, then feedback. Oh, good. Okay, so no need to waste time. You already understand that. So let's explain this. Control C. Okay, so what's this one saying? Okay, so once we have, like you just explained it now, once we have planning, the planning stage, the coding stage, the build stage, and the test stage. So what just happened here, from here to here? What did we just complete?
Continuous integration.
Correct. So that's why you have it. Look at the diagram. Continuous integration. So the interviewer will ask you, at what state do you see, at what step do you see that you have completed your continuous integration? You are now ready to release the application after testing.
Okay.
After testing. So build is the most important thing as far as moving to the next stage is concerned. But the build is not considered, the continuous integration is not considered complete until you test your code. All right?
Okay.
So after the continuous integration, what happens next?
Continuous delivery.
Continuous deployment. I'll tell you the difference.
Deployment,
right?
Yeah. Okay.
Continuous deployment. All right. And basically what happens is the code from here is released into this place. Meanwhile, at this place, we're talking about code. What do we now talk about once we cross here to this country? We begin to call it correct. Here it was the raw state, here is the finished state. All right, beautiful. So, and this one is just trying to explain some things you may not understand at this stage, but we'll understand them later. Now, let's go back to the note, just making sure you're not missing anything. So here I will explain the difference between continuous delivery and continuous deployment. See, come back here, Control V. Can you see this? Not so clear, right? Okay. So once you plan, you complete the planning of the project. Every day, the stakeholders will come to the meeting room. They'll be meeting and discussing and doing stuff and writing. And what are they doing? They are planning a new application that they want to launch. After that stage, they hire developers, some Indian boys, some Nigerian boys across. Everybody will be writing code to support this plan. And then that will result to them building the code, testing it, and releasing it to operation. All right, deploy operation. So, like we said earlier on, DevOps, without DevOps, we'll separate these two into development and operation. But with DevOps, everything now is one thing. Everybody's one thing, no demarcation, no work. Right? So DevOps is everything together. When we automate the process so that every time there is a change in code, all of this one will happen automatically. All of this will happen automatically. We say we have continuous deployment. But it could also be arranged such that when there's a change in code, the automation will stop at release. And it will wait for a manager or somebody to come and manually click a button before it now comes from release to deployment. Once that happens, it is no longer continuous deployment. It becomes continuous delivery. So in continuous deployment, it's full automation. Continuous delivery, the automation stops at release. Automation up to release. And then the manual job will be involved to do what? To deploy. So when we say, the application is ready, but we're waiting for the CTO, we're waiting for the DevOps, we're waiting for somebody to come and release it to operations, that is continuous delivery. All right? Of course, we have explained many times what, you have also seen what continuous integration is, and then we've seen what agile methodology. Agile methodology is about the software development. It's not about DevOps. I'm not sure if you get the difference there, but it's specifically related to how the software that DevOps is taking and releasing into operations, how that software is developed. So it stops at the creation stage. All right. But everything together now, we call everything continuous integration and continuous deployment. All right. Of course, the feedback from monitoring, what's monitoring? Operate, monitoring. We take that feedback from monitoring and follow here and come and deliver it back to planning. And planning will now say, oh, sorry, we didn't capture that part of the, we forgot or something. Okay, let's replan it so that we'll not put it into the application. For example, when we're designing this application, we did not know that people from EU would be our customers and would patronize this. So we took care of the privacy law in America because it's an American application, but not EU. So now that we're having customers from the monitoring, we see that we're having customers from EU, we need to put them into consideration. It is illegal to do this business in EU if we do not integrate the privacy law of EU, the GDPR. All right, that's that. Then the now say, okay, please let us get a legal person or let's get the framework or something. And then you now integrate that into the application. And then you have to pass through and deploy the new application that has integrated that governance law into the application. So you see one reason why feedback is important? Yes. So, yeah. So that's the summary for me. I know that that was fast, but if you understand that, then why? Yes, questions? If there are no questions, I'll ask you questions.
Yeah, no questions at this point, yeah.
Okay. So what about the pipeline? What do we mean by pipeline here? We talked about everything but not pipeline. What's the meaning of pipeline? So pipeline is, yeah, I've not explained it. Let me explain.
Okay.
So pipeline is, once we have all of this process going on, I briefly mentioned that, where's my place? Yeah. That, anyway, let me forget that I mentioned it. So this process of writing code from here, it could be, in fact, usually it's such that when you write a code and you build the code, the process of building the code should automatically push the code to operation as application. So pushing the code should result in continuous delivery. So when you build a process that will allow the push of the code to automatically deliver the application to operation, that process is built using a pipeline. So this process here, all the way to here, is a pipeline. What does pipeline do?
Okay.
It automates the process of converting code to applications and then releasing the application to operation. This whole process here, everything is automatic. It happens automatically once this one happens. This automatic happening is what we call automation, right? So you have to write a code or press buttons here and there to enable. It doesn't happen automatically, by itself, unless you prepare it to happen. So preparing it is done using pipeline. So when we say pipeline, we basically mean that the CI and the CD have been integrated together so that a change in CI would automatically trigger the equivalent change in CD. So for that reason, we call it CI/CD pipeline. So all of these practicals we are going to do. All right, some of them may not make so much sense right now, but really practical.
Do we use a tool for that pipeline, or it's just part of the, okay?
Actually, the tool that we use for pipeline is coding. And we call that kind of coding. They are not difficult coding. We call it declarative scripting.
Okay. Was that Python scripting?
Not even Python. In Jenkins, it's called Groovy.
Okay.
It's I'll show you. We'll do it together.
Okay.
So the Python one, as developers, yes, we can also use Python scripting as the DevOps engineer. We can use Python scripting to automate our processes. But there are other scripting languages that are important than Python. If we know those ones and then we now know Python on top, oh, beautiful. But before Python, we should first of all know Bash scripting, which is the Linux class we are doing now. We should know Terraform scripting to provision infrastructure. We should know Jenkins scripting to build our, so there are other kinds of scripting that we should learn first. And then Python might just be the icing on it. Is Python useful for our job as DevOps engineers? Yes. Is it the primary tool? No, there are primary tools. Python will just be secondary. In other words, you might be able to, you can get a job. You definitely can get a job even when you don't know Python, because there are other tools that will do the job that Python would have.
Okay, got it.
All right. So that's it. That's the summary of all. All right, so let's take a short break and then come back and then we'll go to practical. So for practical, we're going to go to GitHub and create an account. And then we'll start to learn Git.
Okay. How long do this break? 10 minutes, 12?
10 minutes.
Okay.
All right, welcome back. All right, so what you want to do now is go and create a GitHub account. Do you already have one? Are you here yet? Can you hear me? Can you hear me? Are you muted? Can you hear me? Hello? There's a problem. Hello? You can hear me? Oh, that's good. I'm sure it's from your end. Hello, can you hear me? Mhm. You want? Hello, Victor. Hello? Hmm. Hello, can anyone hear me?
Yes, I can hear you. Can you hear me?
Yeah. What was that? Was that Chidi?
This is Chidi. Yeah, this is Chidi. I had to use another different headphone and reconnect.
Hear me now. Okay.
Yeah, I can hear.
The
Let's
problem has it
see.
from your end all along.
I don't
Okay,
know.
so Victor is here. Victor, can you hear us?
Yes, I can. Sorry about that.
Okay. So class was meant to be 6 o'clock. You are just joining after 7.
Sorry about that. I've been waiting and waiting and waiting, and I didn't know. I zoomed off. Sorry about that.
And then I tried to call you.
Yeah, I saw your text and everything. I was waiting, and I
Where are
guess
you?
I was Maryland.
Okay, so you are just
Yeah.
1 hour ahead.
Yeah, I was actually waiting before the class, and I said, "Oh, I'm 1 hour ahead." So I just said, "Okay, let me go do one or two things before." And yeah, I zoomed off. I wasn't even there when you sent the 20 minutes text. That guy is 20 minutes to the class. I'm like, "All right, no problem." And
Okay.
sorry about that.
All right. So yeah, we've done 1 hour of theory. So you watch all of that in the video.
No
We
problem.
took 10 minutes break, and then we return to see that the
Mhm.
mic wasn't working. That's what we're trying to resolve.
Okay.
So now you are here. All right. So let's go back to class. So let's start the practicals now. So practical will start from here. Yes, I was asking if you already have anyway, it doesn't matter. I was asking if you already have your GitHub account. So we go to GitHub and set
Yes.
up one. Okay, who has one? Who said yes?
I do, Victory.
Victor does. Okay. What about
Yeah, I
Chidi?
do
Chidi,
as
do you have?
well. Yeah. Yeah, I have
Okay.
GitHub for my own personal projects. Yeah.
Yeah. Okay. So we'll just use your existing GitHub accounts. So let's go to
Okay.
GitHub. So we don't need to create new ones. So just go to github.com. All right. So this my GitHub. So sign into your GitHub.
Looks
I
like
don't know if
your
you're already.
screen is not presenting, Mr. Aki.
Oh, okay.
Yeah.
Share screen. Okay. Yeah.
Yeah, I can see now.
Yeah. So I came here by entering GitHub. All right. So for this one, you are going to go to your avatar, and then you go to settings, and then you go down to developer settings, and then you go to personal token, and then you go to token classic, and then you generate new token. Have you already done that? Hello, Yana.
I said I'm not done. I'm trying.
Okay, so if you have not done it, let me start all over. All right, so we'll go to GitHub, and then we'll go to settings here. Click settings. Are you on your system? Are you working?
I'm trying to set it up.
Okay. So go to settings, and then scroll down to developer settings. And then take personal access token. So this is going to be your password for your DevOps work. And then you take token classic, tokens classic. All right, so generate a new key pair. You take the generate new, not key pair, sorry, new token. So you take that, and I log back in with my phone. All right, here I'll give the token a name, maybe my token or whatever. All right. If I want it to expire in 30 days, which is a good security measure, I'll do 30 days. In 90 days, or if I don't want it to expire at all, I take no expiration. If I leave it at 30 days, then I'll just click the Click all of the buttons here. The ones to the extreme right only. But that basically means even though you don't need them all, it gives you access to everything that GitHub can. You can delete repo, you can write discussions, you can do admin, enterprise, you can do audit log, you can do code space, you can even work with Copilot, and so on and so on. And then you say generate token. Me, I'm not going to generate token because I already have an existing. So in your own case, click generate token. All right, did you click that? What did you see? Yeah, what's your progress?
Trying to even just open mine up, and I just got my GitHub account opened. So
Okay, you cannot open your GitHub account. Take your time. Don't.
I've opened it. I've opened it. So I've forgotten the first process because if we're going ahead,
I can share my screen.
Let's do
if
it
that
one more
works.
time. So go to settings here.
Settings, okay.
Can you see my screen?
My view is a little bit.
So do you see the menu under your avatar? So this is my account. So go to settings under your account.
No.
You can't find settings, yeah?
Is it the top left or the top right?
Are you seeing my screen at all?
No, I'm trying to.
No, simple question.
Yeah,
can you see my
I
screen?
can see
Can you see my
Akin, yeah.
Yes.
So do you see my cursor, my arrow, my mouse key?
Okay.
Do you see where I'm pointing?
Yes. Okay, now I see.
Yeah, that's what you follow now.
Oh.
So you click there and then you click settings here. Look at this.
Okay,
So when you click settings, okay. So now you're on this page now, right?
Yes, sir.
You scroll down at the bottom of this left menu. Do you see developer settings?
Got it. Person.
Developers settings here. After that, click personal access token.
Okay.
Yes. Personal access tokens, and that's what brings you. And then you take token classic. Classic is the one that has always been. Beta is the one that they are trying to bring. So take the classic. And now you say generate new token. Look at my screen. Generate new token, classic.
Give me a second. Something is written. Okay.
It's probably at the bottom. I see the button. Yeah, all the way to the bottom. The new.
Is there a new screen?
Yeah, for us it says new personal access token classic, and then we have to scroll down to see the green.
Okay.
Yeah.
Okay.
Do we select
password?
Everything? Workflow, repo, read, write, delete, admin.
You said we should do 30 days. leave it at 30 days, right?
That's up to you.
Okay.
You can choose no expiration, you can choose 90, you can anyone.
Okay.
This is a personal system. It will not be changing. Maybe you don't know expiration.
Okay. So no repo.
Select
Repos.
workflow, right package, and so on. You don't really need them. That's not compulsory, it's optional. You can select the first three, and then that would do. But if you like, you can select all of them. And then after you selected them all, you go to generate. All right, so did you generate your token?
Yeah.
Okay, so
I'll
copy your
just
token and save it somewhere. In my own case, I have saved it here. Got my token here. I saved it as part of mine. It expires every 30 days anyway, so it will not. So save your own where you can always copy, because you will need it very often. You need it frequently.
Hold tight, let me see. It's supposed to calculate blank. That's what I'm talking about.
You know how to copy the token? Okay, so Chidi, you completed yours?
Yes, completed.
Have you copied and saved the token?
Yes, I saved it.
All right, so I guess we'll go on so that when you watch the video, then you can see what you are doing. Okay. All right, so now that we have the token, we have saved it. We have generate token. Okay, so we are good. So we'll come back here. So the first thing I need you to do now, do I have any public repository? Let me see if I have a public repository. So I'll come back here, go to the item. Repository. All right, so private. Okay, let's take a public repo. Let's take this. All right, do you see this sign? It says fork 0. So go to my repository. You go to my repository here. When you get to GitHub, look for the item. When you get to GitHub, come here and search for the item. Click search. For the item. Did you find anything?
Yes. You want us to fork DevOps basic, DevOps
Yeah.
uppercase?
How many repositories do you see? You can fork everything.
Okay. I
How
see
many?
all, but I can do one at a time.
How many?
Your public.
Sorry.
How many?
Where's the fork icon?
How many people are not just communicating with me? How many repositories?
Three. DevOps, class, demo project, and AWS, ECS, Docker.
Yeah. All right. So the question is, you say, where do we see fork? Let's go back.
Yes.
So let's go here. You see it? Can you see my mouse? That's where the fork.
Okay. Yeah, this one is not public. This one is private, Mr. Akin.
Yeah, this one is private. So yes, I know. I'm just showing him where the fork.
Okay.
So click the repository one by one and click fork. That way you have a copy of my repository in your own repository, especially the DevOps Basic, which is the one we're using today. So fork the DevOps, put in the name that you want to call it in your repository and say fork. So that basically copies the repo into your own account. All right, so have we forked all of that?
Yes.
Having a different screen and not saying.
So what you do is click DevOps Basics. Click DevOps Basics. Did you see DevOps Basics, Victor? Did you see this one?
No, I did not. I went to the search bar. I typed theITern and.
What did you do, Chidi, to get to the item?
Yeah. See, you have to put on your search bar github.com/theITern and then / so it takes you to the home of his page where it's showing right now. So just on your search bar where you type all your search address.
What it's saying is this. Can you see my screen now? It's saying type github, then / theITern.
Okay.
Yeah, like that.
I went to the search bar.
Yeah, that's why I directed it. So apparently that one did not work.
No. And say theITern.
Yeah. iTern one.
Okay, I'm there now. I said, thank you.
Okay.
So which one are we going?
Yeah, you can open the 3 in a new tab. Yeah, you can open all of them in new tab and then you'll be faster.
Apparently Victor is not that strong, so we just take it one by one.
Sure.
Okay.
So fork that one, click fork. And then put a name here and say create fork. That's all. That's the only one we need right now. You can always fork the rest later. Once it works for you on one, repeat the process for the other one. So did you successfully click fork for DevOps Basics?
Yeah.
Okay. All right, so now you have your token and then you have forked your first repository. So let us start. Let us, you guys know how to use your ID already?
VS Code, yeah.
Okay, you have your ID set up, your
VS Code, yeah.
Your VS Code, oh, beautiful. All right. So for your class, let us create a project and start to work now. Let us come here. Let's go to folder. And then let me go to this directory. This is a general class. So let me create a folder. Yeah. and call it new. New folder. Let's call it January. Okay. So inside this January class, yeah. I hope you guys will follow. I'm going to put my key pair. Let me put my key pair in there. I have my key pair that I use in Windows. I'm going to copy that. The item key pair, Control C, and then go back to January class and put my key pair, Control V. All right. So do you have a key pair? Have you ever created an EC2 in cloud? The key pair that you use there, did you download it?
Yes. Let me see if I can.
Chidi, have you created an EC2 in cloud before?
No, I haven't done this.
You have not created an EC2 in cloud before?
No.
Okay.
And the key pair should be a perm file, right?
Should be what?
The key pair,
yeah,
I'm saying, is the perm file.
Yes, .pen.
Yeah.
So we can just touch it, right, on a terminal, right?
Don't worry about it. We'll get there. I'll show you how to do it. For now,
Okay.
Don't worry. All right. So, but what you need to do now is create a folder, whatever you like on your system. Just like I created a folder here, and I called it January class. So create a folder. Don't worry about putting the .pen inside. So now that you have the folder, go back to your IDE, open your IDE, and from your IDE, click File, Open Folder, and search for that folder that you just created. In my own case, January class, so I search for it, and I see Select Folder. So I'm seeing the folder here.
What do you want us to do with the key pair file, perm file?
No, just leave it inside the folder. Don't do anything.
Okay.
Make a copy of it to that.
Okay.
All right. So are you here now or not yet?
Give me a second.
Don't that.
Give me a second.
So now that you are here, go to the top menu, click that sign, and look for terminal. Then say new terminal. So that you have this part showing the terminal.
Okay.
All right. So once you are in terminal, did you install Ubuntu yet? Ubuntu.
Ubuntu on WS Code? No.
What terminal are you using? Which of these terminals do you have?
ZSH.
ZSH.
Yeah.
ZSH.
Yeah.
Zshell.
Yeah, we have PowerShell, JavaScript, debug, Sprint Terminal. I haven't gone to the store to download like Ubuntu, all those ones yet, if that's what you mean.
But yeah, because you are not there yet in your training. But can you go to the store and download Ubuntu on your?
Yeah, I can do that.
Oh, okay. So for our training, we'll be using Ubuntu. So it'd be nice if you can download that and install Ubuntu so that Ubuntu will be showing here.
Okay.
So you take Ubuntu and then you'll be ready for practice.
What is the name again? Ubuntu 22.
22.04. I think that's the latest. Let's check. Yes. Ubuntu 22.04. Mm-hmm. So ideally, you do this one in the infrastructure as code. That will prepare you for this class. But no worries, since you are still doing it later, you can just manage it.
Yeah, do we? It's not showing 23.4, but it shows Ubuntu.
No, if you go to the Apple, to what store are you in? Microsoft
I mean
Store?
the extensions on
You
the
need to go and
VS Code.
download. You download Ubuntu first, download it. I can send you the manual. No, I cannot send you the manual.
Oh yeah, we haven't done this, Mr. Akin.
No, you have not done this yet.
Yeah.
So, Victor, are you able to get to Ubuntu?
Yes.
Okay, you did that in.
And,
okay, so
ISC cards.
yeah, I know you have not done it, Chidi, but you said you can go and download it. Can you help yourself with it?
Where do we
At your
download?
time?
That's
You have
yeah.
you have to
The way you
go
talked
to
about
the.
it earlier on, I thought you sounded like you could do it now. You said you go to
It's
Microsoft
very
Store,
easy.
download
Yeah.
Ubuntu.
Okay. Do you have the steps? Because I can. Do you have the steps to download? Because I'm searching on the extensions, but it's my first time actually.
You have to first go to the window column on the Windows Store.
I don't use Windows, so by the way, I use Mac.
Oh, you use Mac?
Yes, that Mac is my personal.
I have to go to.
Don't worry about it for now.
That's
what other terminal do you have?
I have other terminals. I have Bash. I have JavaScript.
You have Git Bash, right?
Yeah, Bash. I have
Can you see
Bash,
my screen?
yeah. I don't have Git Bash, but I have Bash. Maybe I can look for Git Bash in the extensions.
Okay. So what you need to do is after class, find out how to do that for.
Let me Git Bash. Let me see. I saw one.
All right. So for Mac, install remote development extension pack. Open your VS Code, go to extension, view extensions, press Ctrl+Shift+X. Search for remote development. Can you do
remote
that?
Development, okay, yeah.
And install the remote SSH extension.
Says no extensions in the extension marketplace. No.
The new extension, right?
Yeah.
Or did you get to this point?
Yes.
Or it says when it was time for this, said no extension.
No, is it for remote SSH or? Let me see. Okay, I see remote SSH. Yeah. Yeah, I see that. I see that now. I'm installing it. Yeah. Okay. So I just installed that.
All right. Make sure your Ubuntu machine is accessible via SSH. In Visual Studio Code, click on Remote Explorer icon on the sidebar.
I don't have this Ubuntu machine. Maybe there is another tool we need because I used what's it called? Terminus. That's the one I downloaded yesterday.
You need to do something before. Make sure your Ubuntu machine is accessible via SSH. connecting to Ubuntu machine. Hold on. Click on the button to add the machine. Enter SSH connect. Are you sure this is for regular operators on Mac? You need to study. Okay, is this remote? Is this a terminal showing now in your terminal?
Yeah, I downloaded it.
You installed it. So let's see if it's working. The remote share.
Remote SSH, yeah.
Yeah. So maybe that should do the work instead of looking for.
Maybe I should share my screen and show you what I'm seeing.
Yeah, that's how we. That's how we I learned by sharing the screen.
Yeah, maybe I should share my screen so that you can see. I don't think I'm enabled.
Yeah, but I'm not. Let's try anyway. But I'm not a Mac person. I may not be able to support you.
Okay.
Let's see.
I think how they did it was, if I prepare, he went to
share.
Is it www.homebrew.com, and from when you go to the homebrew.com, you'll see a curl command which you copy.
Yeah, share your screen so that we can see what you're.
Okay.
I can support it through.
I have to quit and join again. I have to.
No, you don't have to.
Yeah, because on my Mac.
Hold on.
No, on my Mac, that's how it works. If I turn on the sharing, I have to join again. Yeah, for security. Yeah, but I'll do that and join that quickly.
Okay. For the time being, I don't think this note is complete to support me. I'll have to ask people who have used it. So, do you say you have the part of the note that supports Mac?
Let me see if I do.
Okay.
No, I don't. Let me check.
You have a note, it should be in there.
I know it offhand. You just have to go to home, HOMEBREW.com.
You mean
homebrew.com. Then from homebrew.com.
Look at this. You mean this one, right?
Yes. Then from homebrew.com, you will see the curl command. You have to copy.
Okay, so
paste.
Let him log in so that I can support him to do. Let him share his screen. Okay. Can you share screen now? Let me try the homebrew.com. Homebrew. It's not homebrew.com or nothing is showing on homebrew.com.
Okay, maybe made a mistake, but I know it's home. You went to homebrew. I think he Googled it or something. Homebrew. He went to the Google and typed homebrew. Then it took him to the homebrew website where he can copy the curl command. So I thought it was homebrew.com.
Homebrew on there.
Just going off head. Homebrew. Systems. Well, I have problem keeping up with you guys. Yeah, all you had to do was go to Homebrew, go to Google and type Homebrew like for Mac. Then you will see the Homebrew
You see here the person who has
download.
supported.
No. He's not yet here. I don't think he is.
So hello, Chidi, are you here?
I think he sent a text message there as well. Yes, it says feel free to continue. I will install it later. Let's see what I think, class.
Something is up with my mic, but I can listen. Okay, you can hear us, right?
I can join, but my mic is not sounding.
All right,
I
so
guess
let's continue.
Okay.
Yeah. All right, so let me share screen again. Let me take the screen back. Can you see my screen now?
Yes.
Okay. Okay, so we're here.
Mm-hmm.
All right, so the first thing we want to do here now is to clone that repository so that we have, so first of all, what is this repository? This repository is the place where the codes written by the entire development team is being saved. This repository, DevOps Basics. All right, so this is the place where we explain during the theoretical part that when developers collaborate, they are writing different aspects of a 3 million line code. They collaborate using the version control system. In this case, our version control system is our GitHub. So this is the code. So the first thing we want to do now that we have been employed to take over from this point to build this code into an application and deploy the application into our cloud operations. The first thing we want to do is clone this code so that we have this code in our local repository. To do that, we come here, we come to that, and then we say copy. Under HTTPS, we'll copy this URL. And then we'll return to our VS Code and we say git clone. Git clone what? Clone that repository. We paste what we copied from there. All right? And then once we do that, we press enter. No, at this point, you're not. I just wanted. Okay. Yeah, you are not following. You are not necessarily repeating after me. You just need to listen now. Okay. So the reason I gave you that time was for you to make sure you get the basics right, so that you can practice this on your own. So far you have gotten that right. All right. So you press enter, and now it is cloning your remote repo. Or it's supposed to be cloning your remote repo. All right. So what's going on now?
Maybe disconnected.
Well, let me cut that. Let the screen. Let me try again. Git clone. Then the remote that I copied, I pasted there, and I pressed enter. I don't know why it keeps disappointing. Anyway, so it's cloning now. So this way, I now have a copy. So every morning so usually you do this the first time so that you have the copy in your local repository. So if I do ls-l, I'm going to see that repository in here, DevOps Basics. So if I go to cd DevOps Basics and I do ls-l, I'm going to see the entire codes that makes up this Java code that I'm going to work on. How do I know it's Java code? If I come back to the repository and I take that, and then it comes here, look, it tells me that this is written in HTML, Java, Shell, Bash. The programming language, HTML is not really like a programming language. The real programming language I see here is Java. So this is Java, right? Shell is just Linux commands. Docker file has to do with, yeah, we'll talk about all of that. So this is a Java application. And in any case, I should be able to see it somewhere else. So if I come here, look at it. Oh, Shell. Anyway, it's a Java application. This is Java. I think the reason it's saying Shell is because I copied something from GitHub. I copied some things that are mostly Shell-based from there. You should be showing me Java. But I know that it's Java anyway. Yeah. Anyway, so I'll always know what programming language it is written in from here. Okay, this one is written in JavaScript. This one is written in Java. This is saying Shell, which is mostly HTML. That's the meaning of Shell. But I know that beyond what it is saying, this is Java. All right, so I come back here, and then I now begin to use my Git as a tool to modify my repository. So in the first one or two lectures, we'll be talking about how to use Git to manage my codes here. All right, so ls-l shows me I have all of that. So if I want to delete a code, whatever I do to this code now, whether I'm adding a file or removing a file, I am modifying the code. For example, let us delete that file. Remove my file. Yeah, that is gone. ls-l. Let's remove file 1. Remove file 1. That is gone. ls-l. Let's remove test file 1. Remove test file 1. That one is gone. ls-l. Let me remove experiment, or remove experiment. ls-l. So let's remove what other file? The other files are important. Index.html. I don't really need it. What kind of? Yeah, let's remove it. Index.html. ls-l. Okay, so now by removing those files, I have modified the code. I have changed the code. The code is no longer the same as it was originally. If I do git status, I see that Git is telling me that all of this I have removed from the original code. Now, what I'm seeing here, as far as the code is concerned, is not registered in the local repository of this system. If I do ls-la, I'm going to see that there is a .git directory. It is this .git directory that houses my local repository. What I'm seeing here is not my local repository. This is just my working directory. All right? It is different from my local repository. In order for me to commit these changes that I have made to my working directory to my local repository, which is inside .git, I must perform two commands. The first command is git add dot, which means all of the changes that you notice that I have made, add them to my staging area. If I do git add dot and I press enter, next time I do git status, git, what is the status of my code? If I do that, you see that it is now in green instead of the former color that it was in, which was red. Last time I did git status, it was red, but now it's green. So what does that mean? That I have successfully moved the changes to the code from my working directory into my staging area. staging area is the temporary place that the changes I have made will be saved prior to being saved to my local repository. So finally, well, not finally, the next stage now is for me to move it from this staging area, this temporary area, into my local repository. The command to do that is git commit -m, then I put a commit statement in here. Maybe I just call it my first commit, for example. And I press enter, right? So it means that everything that I had here that I have been doing is now made permanent by way of moving them into my local repository. So for the first time, having entered git commit, my local repository is now aware of the changes that I made to the code. All right? So if I say git status now, it's no longer going to show me the red nothing. It says there is nothing. There is nothing to move from anywhere to anywhere. Every change that you have made is now registered in your local repository. So you are up to date.
Can I ask you a quick question?
Yes.
So those 5 files that you deleted,
yes,
in your Git repository, it's now the first Git pull you actually did minus those 5 files that are in your local, in your local repository, your Git repository at this point in time.
Yes.
Okay.
At this point in time, the original code that I cloned, they are now minus this one.
Okay.
These ones have been deleted. That's why it's showing us that I have deleted all of these files from the original. So you now have the original minus all of them. Okay. Now that you have observed that change, at least in theory, later on I'll show you the local repository. It's too early. Now let us push all of this to the remote repository. So let me go and show you the remote repository. This is the remote repository. So you see that the remote repository has file 1, my file. In fact, how many files are there? Altogether, there are, what's the number of files? Okay. So just know that all of the files are still there. Now I'm going to push from my local repository to this place, and then you see the difference. Let's go now. So the final command to push is git push. Git push what?
Period.
Origin.
Oh.
Origin master. There's something I should have taught you before this. This is where I'll go back with. So git push origin master. Then ask me, what is the username of the repository that I want to push to? The username for my account is theITern. So I go there and I say theITern. And if you are the right person to push codes to this repository, then what is your password? It is this password that we created when we said generate token. And I ask you to save it. So you must save it and you must know it. In my own case, I saved it right here. So I'm just going to pick it from Ctrl F, token, and then I'll just take it from here. So in your own case, please make sure you have it handy. Ctrl C, and then I come here and I provide it. And then I press enter. Now it has pushed all of my changes in the local repository to the remote repository. If I take you to the remote repository now, the last push that I had was 2 weeks ago. But if I refresh, you are going to see that only 3 minutes ago, I made a new push. And in this new push, the file 1, my test file, they are all gone. They've all been deleted. So the ability to take codes, modify them, not necessarily as a programmer, that's why we call them administer, manage the codes. We do that with Git, and we just saw an example of how that is. In the same vein, I can decide that, this file, there's something not complete about it. I want to modify it. I can equally come here and go to that file, ls-l, let's go to Jenkins file, for example, even though you don't know what it is. I'll say vi Jenkins file, and then this is my Jenkins file, and I'll come here and I'll say, let me just add space. I do and I add space. You know that by adding space, I've modified it.
Yeah,
yes,
anything.
Anything I do, I've modified. So if I press enter and I say, JIT, are you aware that I have changed something? I would ask that with JIT status. And it says, yes, I see that you made changes to the file called Jenkins file. And it's going to say, okay, now that I have made these changes, it's only available visually. I'm only seeing it. Now, effect it by saving it permanently to my local repository. The command to do that again is git add dot, which means every change that I have made, irrespective of how many files, just add them, send them to USC. But on your way to USC, go to the airport first. That temporary airport where we stop on our way to USC, we call it staging area. So I press enter. It's now in staging area. I say git status again. It's not going to tell me you are no longer in your house where you were read. You are now at the airport about to board. This is green, which means staging area. All right. And then the second command to move it from the staging area to the destination now, which is my local repository, is git commit -n, then put a commit statement here. Maybe we call it my commit 2. All right, we enter that. Now I have successfully moved the changes. The changes that I made are now reflecting in my local repository. So if I say git status now, it tells me everything is clear. You don't have anything to save to your local repository. There is nothing in staging area to move into your local repository. You are good. The only thing you have left to do now, if you want, is to push this change from your local repository to your remote repository. We call it publish, to publish your local repository to the common place. Because while it is still in your local repository on your system, the company is not aware that you have worked for them. It's not aware that you have done anything, you have changed the code. It is when you successfully push it to this company code repository at the end of the day that they are now aware that or what is not here, they don't know. So for you to say, oh, I have finished the work. Now let me report it to the company repository. The command now is git push. Git push origin master. Exactly. So again, it's asking for your username and pushing to Apple, the item. And then my password, I don't have that offhand, so I quickly go back to where I saved it, copy my token, which I generated, and then come back here and right-click to paste it. Again, that is pushed. If I go back to my remote repo, you see that my last push was 7 minutes ago. But if I refresh, you are going to see that only 1 minute ago, there was a new push. The commit ID is 5DDD. And if I come here, you are going to see that the commit ID for this new push, you can see right here, is 5DDD. We'll talk more about that. But you have an idea now how I can use the command git to administer, to manage my code. Right?
Yes. Yes. Very, very impressive. Yeah.
Okay. Thank you. Now, let me go back to the basics because it looks like we've done something. So having created the version control system where we pull our code from, and having used this manual, which I'm going to send to you right away, to learn how to generate your personal token, and then how to go to settings, and then click developer, blah, blah, blah. And then having copied your personal token and saved it there, the next thing you should be doing actually is to do sudo apt update. Every time you want to start using a new program, a new package, it's advisable that you do that. We'll do sudo apt update or Ubuntu. All right.
Yeah.
So it means go to the internet and download all necessary packages to update this particular one. Because sometimes you have error trying to run a command if the package is not updated to that command. So this is basically saying update my package. All right. So what's the problem?
You get to
Okay, so
most of the updates.
sorry?
I say it looks like it's still getting most of the updates.
Okay. So let's just leave that. Looks like I've not updated in a while. Usually it should just tell me nothing to update. And then sometimes, although I don't want to do it in this case, you may want to, depending on what you are doing, you may want to also upgrade the operating system. Not just update it with the latest changes, but also upgrade the version to the latest version. And then it is after you do that that you now do the git clone that we mentioned earlier on. So git clone means make a copy of the company's repository into my local system so that I can edit, I can manage, I can administer the codes directly. All right, this is unusually long. All right, so I'll just be patient. Okay, looks like it's done. Let me do that one more time. Let's see. I said git sudo apt update. Like you suggested, I'll just be patient. Yeah, it's done already, but I just wanted to see.
It would take as long as the other time.
Yeah, normally it doesn't take this long. Connect to apt release HashiCorp. HashiCorp has to do with Terraform. Okay, I'll have to check my system, but I feel there's something unusual here. But not to worry, at least it's not hanging. All right, so now you see the significance of that. Even though the real command we want to run is this, it's good to wake the system up with object. And then normally we say git init. Git init is the command that says initialize git. Git init, initialize git so that I can start to use git. In fact, for some other operating systems other than Ubuntu, I will need to do git apt install. Sorry, no, sudo apt install git. But Ubuntu is already made for this kind of job, and it's already pre-loaded with so many industry-friendly packages. For example, git. So if I say git init, it's going to tell me git was already initialized. It's just re-initializing it. So what I'm saying in one word is, with Ubuntu, you don't need to install git. You don't need to initialize git. It's already done. And when you do ls-la, you will see all of the hidden files, and you see that git is one of them. Anywhere you see .git, anything, it means that that system is already prepared for that. Okay. You see .java, .maven.
Yeah, it's also pre-configured for Jenkins and Docker.
No.
No? Okay.
No. That one, if you are seeing it here, it's just because I already installed it.
Okay.
Yes. But for Git, yes, it's pre-configured.
All right.
If it was pre-configured for Jenkins and Docker, I'll be out of work. I'll not have anything to teach you guys anymore. Anyway, so let's go on. I hope I'm not rushing. Are you getting what we are saying?
Yes, I am. I hope so.
Hopefully the GD is also getting.
GD is.
All right. So to connect
Can you hear me? I'm getting.
Yes, we hear you.
All right. I fixed it. Yeah.
But I wanted to text you to find out how you were doing.
Yeah, I'm able to follow along. Yeah, definitely.
No problem. So again, in your own case, this is not pre-configured. I'm just using it because so what we want to do first in your case is connect my VS Code, my GitHub account with this correct account. So what I want to do is I'm going to do git config -- global user name. Then I put my username here. So the command is Ctrl+C, you copy from there, come here. Let me get out of this. I'm going to do this command. So this command is saying git configure git to connect permanently with my GitHub account so that every time I'm entering a command here, it is interacting and depositing or pulling from this GitHub account. You are going to ask me for what account am I pushing to? Is always to this account. So I'm linking them together. In order to link them together, I have to enter two commands. The first command is git global global username. The username for my account is theITern. So I enter it there. All right. And then the second command to enter would be the email address that I use to open that account. Right. So I copy, Ctrl+C, and I come here and I say, and this time I enter my username, theITern.usp@gmail.com. All right. Awesome. With these two, I have now successfully linked my VS Code, this terminal, with my GitHub account. And to find out if that is correct, whether I really did that successfully, I'm going to run this command, git config --list. So if I take that command and I come here, it's going to tell me that the account to which I am connected is the ITern, and my username, the email is that, which is exactly what I want. All right, so in your case, you must do that first, and then you do it just once in a lifetime, and then your account is permanently corrupt.
So now, like, for example, you've gotten to this stage. If you exit and you come back in and you come to Ubuntu, you link with the configuration of Ubuntu. As soon as you do your apt update and everything goes through, will it automatically, once you put the git.add, it automatically would
Yes.
you have to go through git add?
So basically, you are saying, is this configuration permanent, or do I have to repeat it every time I come to the system? It is permanent. Once it's done, it's done.
Done. Okay.
So I don't have to repeat it. I don't need to repeat it all of the time. In fact, you can test every time you log into your system, just run this command to see if it is still connected to your GitHub account.
Okay.
So you do it once, and for life, it's permanently connected. Even if you remove the Ubuntu and put another Ubuntu, it's likely that the new Ubuntu will still recognize. It's permanently connected.
So how if we're working doing another job and wanted to disconnect this, how do we disconnect it? So
the command will be git remote remove origin master, but we'll get there. That's the command. The remove will be rm. This git remove remote. Yeah, we'll get there. Okay. All right, let's be learning more commands. So now that connected to our account. Now the command to connect specifically to our repository, to a particular repository within the account, is git remote add origin. All right. So let us connect to our repository now so that you see how this works. All right. So just like we said, git remote add origin, the question you asked, when it's time to disconnect, we will now say git remote remove origin. But for now, to say git remove Git remote add origin. This is the command. Control C. Come back here and say, what is the origin that you want to add? Origin means every time you say send or receive, this is what you are referring to. So I go to GitHub, I copy this link again, this code link, and I come here. In my own case, that's not what I want to. Okay. For class practice, let me use this one for class practice. So in this case, I'll say, I'll put that link here. I'll press enter. Pattern. No such repository or parent. Okay, something I didn't copyright. Let's see. Let's see what I'm doing. Git remote add origin. Git remote add origin. Did I not copy that command well?
No, you didn't copy it.
Git remote add origin, then URL of the repo to connect with. So let me go back. So I go to here and I come here. This is the repo I want to connect with, right?
Yeah.
All right. So I think I know what the problem is. But let me try one more time.
Yeah.
So,
last time I don't think you copied it.
I think I did. Okay, but let's see. So I come here. And I say copy.
Copy. Yeah.
This copied down. And then I come back here and I say paste. Git remote add origin, and then I say enter. Okay, pattern. Not a Git. Oh, that's the problem. This is not a Git repository, so it cannot take Git commands. So how do I know? If I say Git, if I say ls minus la, where is the .git? .git is not here, so it's not a Git repository. So you cannot take Git command. For it to be a Git repository, .git must be there. So I'm in the wrong place. So I just do cd devops basic ls minus l, ls minus la. Oh, I see my Git.
No, it's in there.
Okay, now I'm in the right place. So let me enter the command that did not work before. And I'll say Git remote add origin to that. Okay, so if I press enter, this time it's basically, this is already done. It's already existing, of course, because we did it before. But if it wasn't done, that is would have been it. Anyway, let me not rush. I wanted to quickly remove it so that I can show you, but it's still in front. Let's just take it step by step. So normally I will run these two commands. All right. It is after I have run this set of commands to connect me with my account and this set of commands to connect me with the specific repository in my account that I want to be working with. That is when I'm now ready to start using Git. All right. So to answer your question that I said is still in front, look at the command.
Okay.
I said, I am tired of this repository. I want to connect to a different repository. I want to disconnect from my repository, this current repository. So the command is git remote, remove origin. So if I Control C and I come here and I quickly do git config -- list. So right now I see that I am connected to this repository, right? So let me do git remove origin. All right. So let me do git -- list again. You see, it's no longer there. So I have disconnected, I've divorced, I've disconnected from that repository. It's no longer showing here. So that's how to disconnect from one repository so that I can now marry another repository. If I was working on this project yesterday, and today my Scrum Master says I'm working on a different project, which is a different repository, I'll use this command to disconnect from the old repository I was working with. And then I now use this command to attach to the new repository that I'll be working on today. Let's do that. Let's pretend we want to connect to a new repository. We'll do that, Control C, and then we'll do that. Control C, then we'll come back here and do. For which repository now? Let's go and copy the new project, the new repository we have to work with. For simplicity, let's just use this same one. and then we'll come back here, and then we'll do. All right, and it worked. Try to do this, it told us we're already connected. But now, because we disconnected first, it's no longer showing us that we're already connected. All right. So, having just connected to that repository, then we'll go ahead and enter this command. What does this command mean? Git branch minus m master. What does it mean? If I enter that command here, it means that every time I'm referring to this, first of all, it basically means that there could be multiple branches with different names in the repository. Let's go to the repository. In this case, there's only one branch, and it's called master. All right. So I'm saying irrespective of what this branch is called, whether it is called main, master, default, whatever name, I would always refer to it by master and recognize it by that name. That's what it's called. That's the meaning of it. All right. Makes my work easy.
But you can't have two same master. It has
no,
it will accept it,
branches
right?
with the same name. Sorry?
Okay. Yeah, you answered the question.
Oh, okay. Don't worry, we'll still deal with branches. Because in the field of DevOps engineering, just by the time you get work, you are very much likely to be working in, well, not very much likely. Sometimes you work in only a specific area of this whole training. So I've had people whose job is focused around only JIT. So it is what talking about, so that in case you find work that is focused around here, you have all the tools that you need to excel in that job. All right. So we'll now do this. What's the meaning of this statement? Control C. Control. What's the meaning of this? So this command means every time that I want to say git push origin master, even if I don't say git push origin master, if I just say git push, understand that I'm talking about origin master. So from now on, it's asking me for username. The ITern.
There we go.
All right. So this command is saying, did you notice that when I wanted to push, I do git push origin master? Did you notice that was the command I typed?
Yes, sir.
From now on, because of this -u that I have added, I don't need to say origin master again. I'll just do git push. So all of this is just preparing my environment to be really, really friendly. They are not compulsory, but if I put them, so git push, you just understand what I'm saying. Anyway, preparing the environment, and then okay. Subsequently, push your local repository to your remote repository with just git push. All right. So the interview question is going to ask you, what are the steps that I need to take to, I'm trying not to use the word push, for the changes in my local repository to reflect in my remote repository. So the changes are these 3 steps. So first of all, I do git add, then I do git commit, then I do git push. That's the answer. Not one of them, not 2 of them, all 3 commands are the correct answer. All right. Am I rushing? Everything okay?
No, you're not.
All right.
Yeah, that's cool.
Let's continue. Okay. So to check the remote connection that is connected, that I'm connected, the remote repository that I'm currently connected to, the command is git remote -v. And then okay, no wonder I'm having error. I'm connected to DevOps Basic, but I wanted to push to DevOps Advanced. Oh, okay, this is it. Okay, so I need to first of all disconnect from DevOps Basics and then connect to DevOps Advanced before I can now push my code to DevOps, right? So this is the command that will show you who you are married to at this very particular point. All right, then again, this is the question that you asked earlier on. We already practiced it here. We practiced it here, right? There's no need to repeat it. And then yeah, we've already practiced it once. All right, so this diagram is explaining the concept of working directory staging area. When I do git add full stop, it pushes all of my changes to a temporary place called staging area. When I do git commit, that is when those changes are now moved into my local repository. We saw that before.
Yeah.
And then if I now want to reflect in the company's repository so that they will see that I have done the work, the command is git push. If you want to go in the other direction, you come to work the next day, you are no longer doing git clone. Git clone is used for the first time. Subsequently, you want to pull the changes that have been made to the code since the last time you did git clone. The command will be git pull the new repository, because other people are making changes to the repositories as well. There are over 300 developers. All of them are developing and making changes. If you leave it for 1 second or 10 minutes, it's likely that the codes have changed from what you had 10 minutes ago. So you see git pull in order to draw new code. And then you can see git checkout and git merge. We'll work with these two later.
Quick question.
Yes.
Could you go a little bit higher in your screen on that graph? From before we get to git push, when we do a git push to the remote repository, do we need authorization from like the lead?
That's what it asks for username and password.
Okay.
Yeah.
Okay, got you.
When we see git push, it asks for username and password. So if we're not allowed, then we will not have username and password. And of course, within Jenkins, if you come here, within this developer, all right, so we'll come to settings, the head of the security measures would have added you as a collaborator. So we'll come here. No, this is public. Let's go to private so I show you how to do it. Let me go to private repository, public. Where's my? All right, so if I come to this one, for example, all right, and I see settings, and I see collaborators, I would have added, what's your own email address? I would have added you here first before you are able to push and pull codes. All right.
Gotcha.
So this is one of the many security measures so that not just anybody can push code to. Yes. It is one thing to have the username and password. It's another thing to be allowed to do it by adding people. And then I come here and I add Victor.
Yeah.
What's your
you see it. My GitHub,
yeah, don't worry about it. But whatever it is.
CDMA.
You should do.
Yeah, CDMA, CHIDIEMEH, no EM, no CHIDIEMEH, MEH, AWS. Yeah, CDMA, AWS. Yeah, that one.
Here, right here.
Yeah.
Okay. All right, so I add you, and then you get the email, and then you can join that. So that is one security, and then another security is come here, and instead of just allowing people to clone this repository through HTTPS, I can make it compulsory for you. You don't have any public SSH key. So there are different levels of security. We'll talk more about that under cybersecurity. So that that concept of being afraid as to anybody, no, not just anybody. There are security measures you can take here. All right. That answered your question, right?
Yes, definitely.
Okay.
Thank you.
Yeah. Okay, so Git pull, of course, that is so simple. In this case, nothing has changed in the repository. So if we attempt to pull, let's see what it will tell us, because there's no difference between Git pull origin master. You see already up to date. There's nothing to pull from the remote
Master.
to the local. All right. But if there were changes there that other people have made, then you pull it and you update your own local repository. All right. Okay. Branching. Let's talk about branching. So right now we have only one branch. We can create another branch. Why do we need branches? So Git branch tells us that we have only one branch, and the name of the branch is master branch. So let us suppose that we want to add a new feature to our application. You know, this is the code for our application. Our application is running in operations, but we are the developers, and this is our code. Now, we want to add a new feature. Feature means something that our current application is not currently doing. We want to add it so that in future, our application will be doing it. So we're going to make a copy of our application, the code of our application, so that we'll now be work on that copy. I don't know if you understand, or should I draw it?
No, I understand.
Okay. If
Yeah,
understand,
I get you.
don't need to.
Yeah, I get you.
Okay.
Yeah, feature branching.
Yeah,
feature
I understand
branch.
the feature branch and the main master production.
Awesome.
Yeah, understand that.
So in that case, to create a feature branch, to make a copy of the master so that we can experiment, do our testing, confirm that everything is working on the feature before we merge it to master, the command is git. The command to make a copy will be git branch feature master or test master, whatever I want to call it. In this case, git branch feature master. What do we have? If we now say git branch, we now have two branches. The feature branch, which is a copy of the master branch, and the master branch. But right now we are working on the master branch. Let us change to feature branch so that we can start to work on the feature branch.
That's why that asterisk is on the master.
Yes.
Okay.
So the command is git checkout feature. Right? So we have switched to branch feature. If we say git branch now, the asterisk has shifted to feature. So whatever we do now, we are now editing feature. If we do ls -l, and then we say, so this is the code. Now let us add all of the changes that we want to add. I mean, our production is still going on. Our customers are still working with the original code. Nothing is, our company is still making money. But here we add as developers busy experimenting with new things on a different branch. All right, so let's, what do we do now? Let's just add a file. Let's just say touch test file. Right? ls -l shows that we have added that file, but this is only in our working directory. Git status confirms that Git is aware of that change. So now let us make this change permanent. The command will be git add dot and then git commit -m first commit to where? To feature. All right. And then let's make it permanent. Git what? Oh, it's already permanent. It's already in our, by commit, it's already in our local repository.
Okay, because we added it now, added everything.
Yes. So that is how to create a branch and then make changes to the branch. I mean, assuming that this is the small change that we wanted to make. And now that we have made the change, and then let's assume that the change is good, we have experimented and then everything is good, testing is fine. We now want to, let's see. Okay, we're not there yet. Let's take it step by step. So now you know how to do enter a Git branch and how to get out from a Git branch. All right. So the next thing I want to show you now is this local repository that we'll be talking about. For the first time, let's even look at it and see the files that are in local repository. The command to look at the files in your local repository is git ls files. So what branch are we on right now? Feature.
Yeah.
So git ls files will show us the files in our local repository, the feature. There are many of them. And amongst this one, which file did we add? Which file did we add? We added my test file 1. Can you see it here?
Yeah.
Test file 1. Oh. All right. From the bottom is right there. Let us go into our master branch. So what's the command? Git check out master. So switch to branch master. So if we now do git ls files, the same thing. But look, where's our files? Test file 1.
It's not here.
Is it here? It's not here. So that tells you that the content of the local repository from branch master is different from the content of the local repository for branch feature. That's the whole goal. That the changes there and the changes here, they are separate. They are not the same. They are two separate repositories.
Okay.
All right. So now that we have confirmed, assuming that we have tested, the auditors have tested, everybody is good with it. You know, why am I rushing to that place? Sorry. Let me just follow the command somewhere. Otherwise, I'll jump. So let's learn this command again. And then I think we're learning too much for one day. I think after that, we can relax and revise. And then we'll git log. What does that do?
To see
git,
all your operation.
Yeah? All what?
Today. All the commands you did, committed, or on operations you performed today on that.
Yeah. Yeah, that's fine. That's good. Yes, so all of the commits we have carried out on this repository, all of them will show git log. Because everything we do, especially our commits, is recorded and is logged. Whether they happened 5 years ago, depending on how we configure them to be backed up. 3 weeks ago, last week, yesterday, all of them are logged. They are here. All right, 2023. All right. So
I was listening to someone on YouTube, and it was like, if you're going through an interview, and actually this was 2 days ago, and it was like, and you have a problem. If they ask you what problem have you had, for people like us that are novice, that this is what you just did, like git log, explaining to the interviewer about git log to see how to see where the problem originated from, would be a very good example to use as a use case to answer that question.
Yes. Yeah, that's a very, in fact, it's always in number one.
Okay.
You check your log file to see where the problem is. I mean, whether it's cybersecurity or anywhere, yeah. And then no matter how many things you mention, how many solutions, that's checking your log is very important. It's almost like the number one. Yeah, that's correct. I agree. All right, so git log, you can say, that was too long. Why don't I just do the short version? So you can do -1 line, and it just gives you everything in one bar. I mean, in a simple format. Right? So you can see that this is the commit ID where we said test the cron job. We had another commit, and here we can tell that there was a commit, like we saw earlier on so date at so time. And this error from another log, you see that this error happened around on February 15th around 7.
0600.
And this was the last, this was the last commit before then. So you definitely want to investigate this commit and see what was done and see how you can undo. Well, maybe it's your work to do that. Maybe it's not your work. Maybe it's just your work to recommend what should be checked. But trying to undo what was done here would be a good way to restore your system. All right, so that is commit. How to see the whole log, and then, of course, now that you have seen the whole log, which one are you interested in? You may now want to zoom on a particular one to say, I want to investigate this one. To do that, the command is let's do this demo. And this is what we'll be doing together. No big. Yeah, let's stop there. We've learned too many commands in one day. Are you strong? Can we go on? Should we go on with more commands?
Yes.
Okay. All right. So yes, we're already doing this demo together. So that is what we are doing now. Okay, so finally, the mesh that I was eager to show you. Now that we are done with the feature, so to merge the two of them back to master so that all of the, whatever change we have made in feature will now reflect in the master, we merge them together. We enter the command from the branch you want to merge to. In this case, we want to merge to master branch. So to merge test branch, feature branch to master branch, then we have to be in master branch to enter the command. And what is the command? The command is git merge master feature. So first of all, which branch are we at now? Git branch. We're in master, so we're in the right place. I will say git branch, git branch master feature. All right, so that is it.
Actually, git merge master. Yes. Merge
so
instead
branch,
of branch.
Merge.
No, you want to merge first, yeah.
Yeah. Git merge. Thank you. All right, so that is merge. So last time we checked master, the file 1 was not there. So if we check now, we are going to see that the only difference between the two was this absence of test file 1. Now master will now have test file 1. And that is what this diagram is saying. That whatever was not present in master, the red one, the ones in red, they will now be merged to it from feature.
Master.
Yeah, we merged to master from feature. Yeah. And then if you go ahead, of course, we've done this before, but if you now go ahead to do it all over again, you are going to see that. For branch master, you should git ls files. We are going to see that this one is there. All right, so that's how to create branches and then work on branches separately, merge them. And then once we are done with it, so what branches do we have now? Git branch. We still have feature, but we don't need feature anymore. It's done its work. So we'll delete it. To delete a branch, the command is git branch -d, and the name of the branch. -d means delete. So in this case, it will be git branch -d or
Can you mention the branch you want to do it?
Yeah. We'll delete branch feature, and then for now say git branch. The feature is gone, only master. All right. Sometimes the -d, for some reason, if it does not work, then you force it by using capital letter D. You force.
Yeah.
All right. So git rebase does the same thing like as git merge. Before then, let me quickly show you this one. cd git ls -l ls -l a. So cd.git ls -l a. Let's go to head cd. Oh, I should have gone there earlier. cd head. Oh, refs. cd refs. Refs ls -l. cd head ls -l. So we talked about this being the local repository. So this is actually the local repository. Look at the master. If we did not delete the branch, we would have, in fact, we create a branch. Let's see if we git branch test master ls -l. Yeah, right there. So all of the branches that we have in our local repository, this is where they are actually, this is our local repository. So anytime you hear about heads in ref, this is the hidden place where our local repository is saved, right? But as files, not as a directory, right? So this is advanced and out of scope to go into master and begin to see how this simple thing can be what we are calling local directory. But in any case, this is our local directory. Just to give you a feel of everything we are doing is within there. Now you have seen. Exactly the same.
Because exactly, okay.
Yeah.
Got you.
Yeah. Yes. In cybersecurity, we call that hashing. Okay, so now you know how to create how to set up your repository using how to set up your remote repository using GitHub, how to set up your work environment, how to set up your Git within your work environment and use the Git to manage your code and be able to communicate, use Git to communicate. Sometimes I call it Git, sometimes I call it Git. Not used to one yet. All right, so how to use Git to communicate, how to use Git to manage your repository, that is more like it, between your remote repo and your local repo. And then we've seen some Git commands. Even if that's all the Git commands you know, you have already covered more than 80% or maybe 70% of Git commands.
Funny enough, I have had interviews that if I knew this,
yeah, you'd have nailed them, right?
Oh man.
You are just doing training. How come you have had interviews?
I get lunch. So okay, I went for a DevOps class with some other firm, and what they taught us was just an overview. So, and he said the guy said we should go look for jobs. And they're like, so when I went for the interviews, they're like, theoretically you understand the whole system, but when it came to practice, they were like, "Man, you need to learn some more." I was like, so why am I not getting this move? And I kept doing it over and over till I said, okay, these guys didn't really teach me what I really needed. And as soon as I went through your first Linux class and I saw the curriculum for this, I was like, oh, this is what I really need. And wow, you're a lifesaver.
Yeah, I noticed you on my Instagram that you're always, I say, this man that is always following me.
I'm always on. It was a nightmare. I'm like, what am I doing wrong? I'm doing everything right, but yeah, saying I know it, but I do not know it. So I'm like, what part don't I know? So once you said you were going in depth into IAC, Git, I was like, yes, that's where I know I start during the interview. It doesn't go right. It goes south from there. And I was like, I have to, I'm taking this class. Okay. Wow. Thank you very much.
You're welcome. Yeah, I mean, it's people like you using this kind of knowledge to get a job. That's where the good news come from. Because for every person that gets job, I'm getting at least 1, 2 more persons from there.
Wow.
So it's good for me when my trainees learn, they are happy, and they build confidence like you are building now. And then with that, they can go to attend it.
Yeah,
I mean,
hopefully both of us will get job, Victor, me and you.
We will.
It looks
See,
like
this thing,
this needs
this
like,
thing you just
hands-on.
explained.
Yeah, hands-on, like you said, you did the interview. Let's say we practice this and we challenged each other. Hey, how do you do this? How do you do? And we both practice it hands-on. That part is very hard to forget because you've done it hands-on. And I see that this class, has a training for that.
Let me open up. Like I said earlier, I've done several DevOps interviews. They have never gotten to this far. Not that I don't know, not that the interview, they're like, dude, you're at the end. Give me the codes. And I'm like, giving the codes, and they're like, okay. So I keep telling myself, why am I not getting the codes? So I was like, you know what? So when I took the IAC class, I was like, yeah, now I know why. I know my
because it's practical, because it's showing you what to do, Exactly. Yeah, don't worry, we'll get the job. Don't worry.
No, definitely. You guys, I mean, just first day of interaction, I know that you know what you're doing. You get the job. You're not even practicing, you're already talking like this. By the time we spend 1 full month, 2 months, 3 months together.
For sure.
That's good. So tell me about your first DevOps training. Was it just one training you had, or you had like 2 trainings before this one?
So my first DevOps training was almost like this. Well, it was a Saturday and Sunday with a different firm. And the guy basically, it was like a school. He's just going over how what is DevOps, how long DevOps has to work, all the terminologies of Git, like fork, and like a school, like definition. I'm like, so there was zero practical. I'm not even sure this guy knew, but he had memorized everything and just going with.
Was he an Indian guy or Nigerian guy?
Yes, Indian, of course.
Oh, okay.
Yeah. Indian guy, and it was so he kept bothering me. See, this stuff, when I knew there was something not right, he was like, what you paid for, even though you can go and interview and look for jobs, it's not the main thing. There's an advanced DevOps class. So he wanted me to pay another, is it like $300 more? But I said, at least let me get this, let me understand this class first. And he never came back. They never came back to the advanced DevOps class. So I was like, okay, I've practiced all the assignments and everything, but there was like the Chidi said, there was no hands-on experience. So I was like, okay, let me try and start. And he advised us to start interviewing so we can practice what he's telling us. And and when I go through they were like, wow, you understand it. You understand it from a high level. Okay, when it comes to practical, that's where the hiccup starts. I will start as far as I will pass to the authentication of either AWS. Then when it's start for, okay, what tools do you know? Give me an example. What will you do daily with a tool? I usually go with Docker's containers, and as soon as I start, they're like, you know what? Okay, time is over. Actually, got to be sincere, I figured it out. Went to YouTube, got a job with Accenture as a DevOps engineer.
Wow.
They did my pre-screening, wow. Yes, but the recruiter was angry and thought I didn't know because they wanted to, okay, they offered a non-testing interview job as a SRE.
Okay.
And I said, and I turned it down. And she thought it was because of the money. I was like, and I kept telling them, it's not because of the money. I have spent a lot of time and a lot to get up to this DevOps. And I don't want to go and start doing some observatory task.
Okay, just sitting
get
and watching
all about my
monitors.
DevOps.
Yeah.
And the project manager said, I know what you mean. But the recruiter felt, so when I came back to recruiter, the recruiter felt that I wanted more money because the DevOps Pro that was with Accenture was 180. The observatory
180?
was, yeah.
Wow. Okay, Accenture, okay.
Yeah.
I have some DevOps guys with Deloitte at 120, 110. So Accenture pays better there.
So
Apparently.
So she re-interviewed me. I went through. I've even set an appointment for my lead. She just came from nowhere and said, no, they've revamped the whole hiring process, that she wants me to restart the whole interview. I knew what it was. I was just laughing. I said, this woman won't put sansa for my Gary. So she started the whole interview again from scratch, the technical interview, and look for before she even looked for the guy to interview me, she put me on the bench for 2 weeks. I've done pre-screening. I've sent my pre-screening as a hire. It was just offer letter to talk to my lead, and he will give me my offer letter. She started it. So other people under the recruiter stay asking me. It's like they knew something was going on. So they will ask, are you prepared for your next interview? And I'll say, see, I don't know what's going on with Accenture, but I have already done one technical interview and I passed, and I was supposed to talk to my lead manager. I don't understand why I'm going through another technical interview, but anyway, I feel I will try my best, but if it doesn't work out, I know something is wrong. They were like, just think positive and I think you'll be all right. I knew I was talking. That's why it was me that asked you that question, Mr. Akin, what is System D? Do you know during the interview, he said, do you know Linux? He said, yes. He said, what is System D? System D.
That's advanced part of Linux.
Exactly. So I knew what I was. That was the last question. He said, thank you, have a nice day. Boom, stopped. She emailed me, blasted me. Yeah, you didn't even know System D. I was just laughing. I just said, I replied to her, thank you for your opportunity, laugh out loud. And, and I closed it. And that's why I said, okay, let me stop interviewing. That was the last interview I took. I said, let me stop interviewing and go back. There's some things I don't know. They asked me different questions, knowing that I won't do it.
I mean, now you have the interviewing is a very good thing to do in career, because, in my field, every 2 years I have to interview and see what's out in the market, what they're asking. So now you already have the knowledge of what they are asking and what they will need. You almost even made the finish line. So now with this training, we can work. That's why I say I'm serious. We can work together. If it's a project, we can collaborate and do like a small pet project and put it on GitHub. And if they're asking, you can say, yeah, I worked with Chidi, I worked with this guy, we did this, we did that. And they can open the GitHub, we'll put a README there, that shows what it does, all these things. When it comes to that part in the interview, they say, hey, have you done this? You say, yeah. You say, oh, go to this GitHub. They'll go, they'll open, they'll see your commit, they'll see my commit. If two people are very serious, that's what I'm here for, Now you have the intel, and then you do the practical, and you get the job. You will get 2 jobs.
Yeah.
Actually, saw a guy that said the same thing. He said, yeah, interviews, there are ways to go around it. That truly he has a firm. He's a full stack. He just came from Nigeria 2 years ago, and he's married to one of my relatives. So when I introduced him, he was like, yeah, he doesn't work for anybody. He consults and does. He said, if he really wants to know whether you know what you're saying, he would just say, please give me your GitHub handle. And he goes and see what you've been doing on your GitHub profile. He said, that's the way. If they really want to know. And sometimes as a consultant, that's what they ask him. And he will say, once they see all his commits and all the work he's done, they're like, okay, he probably knows what he's doing, and they'll give him a chance.
Yeah. Mr. Akin, I think you have the 15 projects. We can do that, and that's going to be
of course.
good proof.
If you go all the way,
sure.
I can let you clone all of my projects. And my projects are not small projects. That's why they are not public. They are production grade projects.
I see.
Yeah, they are big projects. If you can even show one of them alone. That's one of them.
Definitely, man. Yeah, Victor, I'm open to work together. Okay.
Yes, please.
Whatever. Yeah, let's collaborate and put heads together, and we get this job. That's the goal this year.
Yeah.
Yes. Please.
Inshallah.
Absolutely.
Thank you. I'll practice more.
Thank you. Yeah.
Once you're going to send us a video of this whole class, right, Mr.
Yes, you have the video, and then you have this note as well.
Okay.
Thank you very much.
I also need that. If you can provide me that documentation to install that Linux on VS Code.
For that one, I need to ask the trainer.
Okay.
So apparently, what he has in the note is not complete.
Okay.
I'll ask him again.
He wasn't online. You can just go back to the note. Go back to the note and show him, because
I
remember
he was not in the class.
No, he wasn't in class when we went to that homebrew. All he has to do is go to Chidi.
Chidi did not do that with us. That's why he's having the report.
Yeah. I can do it. It's just it's 9 right now.
You just have to go to homebrew on Google and download it. Then you say crawl.
Yeah, I have homebrew. I have brew working on my machine. But
anyhow, I'll still ask him for you. If you happen to have completed it before he answers, fine. But I'll ask him on your behalf, because after all, you have registered for the course, so why not?
Oh, sure, yeah, definitely, yeah. No problem. Thanks, Victor. Though, yeah, I have
whatever it takes to support you guys to get a job. I'm
absolutely.
I'll support.
Absolutely.
I'll do.
Absolutely.
All right, guys. Thank you so much for your time. So we'll continue from here tomorrow. Next week.
Monday, right? Okay. All right.
All right. Thank you, Mr. Akin. Have a nice
Thanks, Mr. Akin. Yeah. Have a great evening. Yeah. Feel free to ping me. Yeah. We talk more. Yeah.
Yeah. No problem.
All right.
All right. Bye-bye.